Welcome to our webinar on actionable context. So in the next, depending how fast we'll go, 25 minutes to 45 minutes, we'll go over the problem of too many vulnerabilities and some methods that we see from our customers or from our own research on how organizations can go and use what is the most recent talk about how can you prioritize and make vulnerability data actionable. With me, like Sam said, is Justin, our VP of Customer Success. So let's dive in. Cool. So just to set the stage and talk on why we're here and what's going on. The problem as we see it is that today, software, this is something that everybody knows, is the competitive edge of everyone. This is the growth engine for most businesses. This is where they invest. This is where their differentiation comes from. We're living in a point in time where it is the fastest and cheapest to create new software. So there are AI services today that you can basically describe what kind of service you want to put on, and it's work that dozens of people used to do in the past could be done in an instant. What this means for enterprises and large organizations is that the rate of changes and the rate of new software that's being created is accelerating. And it's, AI is the last thing. CI/CD, cloud, usage of, frameworks and modern, cloud native development is something that accelerates creation of software. With that, there are more vulnerabilities. So when you introduce open source, when you introduce AI models, when you introduce a modern CI/CD, modern cloud, and you start layering up all of these components, the surface to make mistakes grows. And naturally, over the last decade, the industry has invested in scanning tools and a lot of abilities to find risk. So what we see today, and we'll get to that in a second, that there are a lot of vulnerabilities. Wherever you turn on the flashlight and look for problems, you're going to find thousands and sometimes millions of problems. The next thing that connects all of this is that if you are exploitable, the time to exploit a vulnerability is getting faster. So multiple data points we can share later on a call, a lot of data about this, but vulnerabilities are easier to exploit. There is a statistics that says that 25% of all the high-risk CVEs on the day of disclosure, there is an exploit already being written and being actively used. And I think the average stands today on a few, maybe less than 50 days for the rest of the vulnerabilities for an exploit to be actively being seen in the wild. So in a matter of days, and AI is accelerated to that, anything vulnerable that touches an exploitable surface or on the internet gets exploited very fast. All of this together begs the questions of what do you do when you have an environment with 50,000 critical in this case, or a large number of vulnerabilities in your software, and you now have to start taking down this attack surface with just this information. Justin, I'll let you add if you see, how do you see this problem when we are working with our customers and their AppSec teams?
Yeah, a couple points. One is these are not unrealistic numbers that we see. The reality is so many enterprises have so many different kinds of scanners and tools. By definition, they want to find all of these different problems. Obviously, it creates a huge pool of issues. Our customers typically look at these types of numbers, or all customers look at these types of numbers as unmanageable. You can't do a million things. It's literally impossible. So really what most customers do when they see a number like this, whether it's from a bunch of different tools or just in a single tool, is they essentially ignore it. That's the reality of what happens here. It becomes non-actionable because it's too many. It's not clear as to what to do first or second. Even when you break it down, it's still too many. So there's a missing component of what's the further level of prioritization that I can do to help best use my time? Because the ultimate reality is, no matter what these numbers are, whether it's a much smaller number in a smaller team or company, or these large numbers, you simply don't have enough time in the day and people to do these amount of things. That's the pure reality of it.
Yeah. And then I remember when talking to a lot of teams, the definition of critical, if you look at their policies, is something that has to be solved immediately. But the reality is when you run a tool against your environment for the first time, you find even 50,000 is a number that you can't, any way you spin it, it's impossible to deal with all of these problems ASAP. So it's still not enough to do this. The point I want to go like one step further, talking about this discussion about risk, is that today every organization uses severity. So every vulnerability is being classified into one of the severity, and severity is the universal language everybody speaks. Every tool, every dashboard, when you look at this, the first thing they do, they break down vulnerabilities into different categorizations of severities. From what we see, the most organization, or almost all of them, this is the first step they do. The first thing they do is they take a vulnerability, they classify it, and then this decision determines everything downstream. So if it's critical, it's going to be solved ASAP. If it's high, probably a few weeks or some SLA. We have seen a lot of organizations, it's going to be an interesting poll to do, that will never ever touch any low vulnerability. And you ask them, will you do this? They'll say, even if it's for some reason we find this vulnerability important, maybe by a chance we will, but there is a almost like 99.9% chance we'll never fix any of the low severity vulnerabilities because there's so too many of them that we don't even look at them. What do you see? How do you see customers deal with it today, Justin, about this severity decision?
Yeah, for sure. Critical and high is still king. Like most customers will still almost always measure the success of their program based on how they're managing their critical and their high. They literally ignore the medium and low just because they, as we said, they don't have enough time that they do it. What I find to be even interesting and probably definitely something that the industry is trying to fix is because the criticals and highs even themselves are so, there's so many of them, what ends up happening is these customers start to create what I call shadow audit. So instead of the pure definition of this policy creates this severity of this issue and it goes in the critical bucket, there's some sort of negotiation that happens behind the scenes of, let's say, the security team going to the development lead or the security champion and saying, listen, we know you can't do 40 things in the next 2 hours. How do we figure this out together? And there's this really inefficient process of trying to further prioritize and work around SLAs. And it's very specific to the business. Like, a large financial has to deal with criticals just based on their policy, where another business may not be so urgent. But the reality is, no matter what the driver is of you fixing the issue, you still have to work around the problem because it's just too unmanageable.
Yeah, and you touched on that. I'm curious, like, do you see a difference between industries or anything how different industries or different types of organization handle this risk?
Yeah, a lot of it comes down to workflows. So a lot of large enterprises, specifically regulated enterprises like financials, specifically, will have workflows set up for criticals and highs. Automatic ticket is created, automatic SLA gets put into place. Obviously, there's a lot of nuance to how to handle that ticket and close that ticket within a certain amount of time. But basically, most of the people that are tackling with urgency the criticals and highs are doing so under a probably unrealistic set of expectations. Like, I need to do this in 48 hours. I need to be able to show an auditor that was closed in 48 hours. So really, almost every customer has figured out some sort of workaround to make this work for them. And the challenge is that this is never ending, right? So like once I fix all my criticals, more will come in tomorrow. So it's a really difficult problem because based on the industry itself, there's a lot more urgency of getting these things done and being accountable to not having them done. So that's where you see the difference, is real SLAs with teeth that customers actually have to follow versus, yeah, we're supposed to do these in about 48 hours. If it's, it's 60 hours, it's okay. It really depends on the industry.
Yeah. And then going down, it might be fair to say, you can disagree, but it's fair to say that the compliance or the regulatory slash policy component plays a role here in how you treat these vulnerabilities. So some organization
Yeah,
have this incentive, and they have to fix a critical because it's a critical. If somebody says it's a critical, even if it's a decision, a tool, an analyst team belonging to some vendor made, now this organization has to deal with this critical because that's the policy.
yeah. One more thing I'll add is that when you go down the path of we'll actually talk about it in the remediation section, but it all comes down to consistency. There has to be a consistent model of why I did what I did with the time that I have. And that's a really important topic.
Yeah. So the next step down into this severity is that, large organizations use a bunch of tools to generate application risk, whether it's your source code scanning, STAS tool, cloud scanning, container scanners. Basically, these tools make determinations on the severity of a vulnerability. The most common when we see a CVE, and these are the large volume of vulnerabilities, they use CVSS, and it's been it's very common today to say that CVSS is something that, it's the first simple framework, but it's very, very detached from the business. And looking at CVSS scores and saying, okay, this is critical because this is how the vulnerability is rated according to some vulnerability database is very, very, I would say it's guesswork. And we compare that to things like, looking at speed or looking at temperature. So you look at speed of 35, could be a high speed, could be a low speed. 35 degrees, in certain situation it's cold. In certain situation it's actually hot. It can melt icebergs. So CVSS score, as an example, is a number that really doesn't mean anything. 9.5 is high in the scale, but it could be really not important for the business. Same as a very low number, maybe 5 or 6, might be a really critical because it's really sitting on a critical path and it is exploitable. And one thing you need to remember about these vulnerabilities, they are exploitable. Some of them may, somebody could create a denial of service attack using an exploitable vulnerability. It won't get the highest CVSS because this is not remote code execution or some very fancy attack, but it could take down your business through a medium vulnerability that happened to be on an internet-facing critical service. So CVSS score is something that most of tools today rely on is very, very, very lacking in context. And then the question is like, what do we need? What information do we need to make the decision? And I want to introduce two categories of information. So the first thing is we want to understand the business risk. We don't want to really know the sort of like very, very detached risk of this particular technical risk of this vulnerability. You want to understand the risk to the particular business, to our company. So we can make a decision about the urgency. Is it really critical? Is it really low? Should we do this? The other class of information, which is also interesting, I'm going to touch on, is information about the remediation. So there is a little bit of psychology here, and probably maybe Justin can talk a little bit about this, but this is information about, can we really fix that? And it's not really an information about risk, but in many decision-making processes, it comes into play because if you can't really fix it, then what do? It's a different conversation. Or if it's very easy to fix, sometimes you can skip the conversation about business risk and say, okay, let's just deal with it. It's very, very simple. So also the remediation context, like what can we do or what's the solution here, or is it a solution here, is also useful information when making a decision. Let me know,
Yeah.
Justin, if you got any insight on that.
Yeah, I do. I think this is a really strong point because if you go back one, what this becomes is these are languages that security teams can speak with, and really it comes down to communication. So at the end of the day, every security practitioner that I talk to that has application security programs is scared to death to go to a developer or development team with what they think is a problem and not have enough context to really make a case that that person should actually spend their valuable time in fixing that issue. So these two pieces of data really enrich that conversation, right? If you can translate the problem into a business impact, which is business risk, that's a huge reason that the developer should do something they did not plan on doing. The second is the remediation action. Having information that saves the developer time of what to do or how to fix something really helps them not waste time in doing that research, or even pushing back and saying, this is not something that's there. Two things happen. One is there's a faster communication cycle of getting the problem fixed. And the second is there's a trust built up between the two teams, which is really the heart of all application security programs. And the challenge they have is the security team sees the risk, the development team sees the time and effort, and a lot of times that communication doesn't happen and just nothing happens. So these really help to make sure that both sides are on the same page as to why they're asking each other to help fix the problem.
Yeah, absolutely. Going even one step further, let's look first at this business risk. Like, how can you really take a vulnerability and analyze what is the risk to the business? So basically, it's risk management theory 101, but basically you want to look at two things: the chances of something happens and what's the impact of this happening. And in vulnerability world, this is, can this be exploited? Or what's the chances of this vulnerability actually being exploited in the context of my application? And then the second thing is, what's the impact of not fixing? So what happens if I ignore that? I deliberately said not fixing, not the impact of exploiting, because even if it's still sitting there for ages, you could fail an audit or breach some kind of a contractual agreement with a customer that you have committed to release a patch. So not fixing is the thing that creates the impact. It's not necessarily the breach itself. So these are two questions, like, is it exploitable, or what's the chances of this being exploited? And what's going to happen if I ignore that or not fixing this? There are multiple factors you can look into when you try to answer these decisions. And actually, when teams get a vulnerability, they do this instinctively. Like, they don't need to, if you make a discussion about a vulnerability, and you start asking, okay, like, what's happening? Is it exploitable? Is it internet facing? So we'll cover a lot of the stuff that legit, even as a product, can cover for our customers, and some of the new things that we're looking into. But there's certain things like, is it internet facing? Are there compensating controls in a way? If I have multiple other controls, then this reduces the likelihood. Is this reachable? Meaning, is there a path for the vulnerability in my code or in my application? So the actual module or code line that's exploitable can actually get executed. In many cases, in open source cases, the answer is no. Is it being exploited in the wild or not? Or maybe it's a theoretical vulnerability that nobody has proven can be exploited. So this is a lot of questions that ask, like, what is the chances that this will happen? About impact, we can look at, if this happens, does it break my compliance? Going earlier, we talked about financial institutions or regulated industries that require to fix things within SLAs. So unless they go and claim that something is not exploitable or risk accepted, they have to do something. They have to address the vulnerability. So even in the case where, say, well, it's a medium risk, it's a high risk, I'm not sure I need to fix it, there's still this regulatory compliance to do something about it. What happens if the application goes down? If it's my main service, maybe we don't want to take chances. Is there sensitive data or privacy involved in the path of that vulnerability? So can someone leverage, exfiltrate, or take data? If we're able, in the end, to get this alignment of business risk into application, and if we take this to, like, the high level, what I call here, like, true risk, if I actually can measure in a good approximation the actual business risk for a vulnerability, the benefits are huge. So you save time, because ultimately not all criticals should be criticals for your business. So it should reduce the number of criticals and highs that you need to deal with. On the other hand, it should bring up things that you thought weren't criticals and actually are. So it should surface a lot of things that are actually threat to your business and were hiding in medium land or low land. It creates trust, because when security comes to engineering with something to fix really urgently, they are backed by data that says this is a real thing. And eventually, then all this thing leads you to, as we started, focus on what's important. Like let engineering build features and take the company forward, and work less on security. So the analogy I like is that AppSec is a tax. You have to do this. It's like a tax imposed on you. This is reducing the tax load. So the more you understand the true risk, you get to the most efficient place where you're actually just focusing on the things that are risk to the business, and you make better business decisions. Uh, like Justin, I'd love to hear what you have to say about this, but also what are
The-
also the implications where somebody doesn't have this alignment? What happens? And this is a case for a lot of organizations today. It's very hard to be there. So what happens when you're misaligned?
I think the second part is the easiest thing to answer. What happens most of the time is the reality is customers aren't maximizing their time to reduce the most amount of risk. And really the obvious reason for that and why that's a bad thing is you could miss the thing that actually would hurt you. Like if the logic is that you don't have enough time in the day and you have to pick and choose where you're going to spend your time, then if you choose wrong, it has obviously a negative risk impact to your business. But the general thing that we see the most from customers is, I think you said it perfectly, truly measuring business risk. Like that's a really hard thing to do. So really, if you're going to boil it down, there's two factors. One is stuff we know, stuff we can find out in very creative ways. And then also it's the customers telling us this is what this application or group of systems does. And that's why it's important to us. It's something we would never be able to know unless they told us. So the combination of both helps the customer get to a pretty good point where they said, this is what my priorities are. These are the things I want to protect. And I need you to tell me if anything changes in that environment so that I can actually readjust my priorities and risk based on things like internet facing, reachability, things that are becoming dangerous that weren't previously dangerous. So it's the 1-2 punch of knowing, working with a customer to know what their actual systems do and why they do them, and then actually making sure that there are certain risk factors that we're measuring that those priorities don't change, and always be kind of alerting them on those changes up and down.
Yeah. And you'll be surprised like how many of that, it sounds simple, but there's things that are very hard. So when a vulnerability is reported on the code level, for example, in large enterprise, it's sometimes very hard just to attribute that code into which application does this affect, and then like have this information flow down into this calculation. So even determining which applications am I is the vulnerability affecting, it's not an easy question to get. Even if you have an information about what the application does and how critical this is for the business, then just this attribution is a challenging or a tricky thing in some cases. So basically the method is to do something like this. And this is very, very, very simple, like cheat sheet for like, let's create a formula. Let's break down the impact and multiply by exploitability. And we get these rubrics that we can say, if everything is maximum impact and very highly exploitable, then this is obviously critical. The other edge, if the impact is very low, if it's really not exploitable, then this is like no bother land. Like don't even look at this vulnerability. It's not worth anybody's time. And then if we get, and we'll, as we get down in this conversation further, we will get down to some interesting ways to calculate this, but you can start filling out like, how do you calculate impact? How do you calculate exploitability? And sort of like create your own chart and policies into, okay, what is the factors that I'm looking into? And we've seen some organizations that, for example, look at application context as something, which application handles the most requests from customers, which applications actually generate revenue. That would be the metrics that will pull me right on this axis down here, and which applications are regulated or FedRAMP compliant. So how do I move right on this axis, and how do I move up? If all the information we have is CVSS, we can't really make any movement in any of this axis. We need additional info based on the setup of the vulnerability, or the exploitability of that, or maybe threat intel about this, or something about the business, about the application itself and what it does for the business. So the next slide will show a little bit of how legit does that, how legit helps you move to the right and upwards. discover what your parameters are, and then make this better determination. So like very going forward, like one example would be, we found a vulnerability in a code project. We know the full context. We can say this code project actually is deployed to the internet through an API. It is handling PII. The vulnerability is exploitable. There is sensitive data involved. So all in all, we can make a confident determination that this vulnerability is something critical, and we have to solve it ASAP because right now we're in great danger. There's some certain cases where this thing is actually, you'll see the opposite example. It's very high risk and severity, but the situation shows that it's actually not really, it's okay to make a decision to postpone it or even accept a risk for a certain time frame. The next thing I want to talk about is the remediation context. Completely different set of information. It's not related to the risk, but it's about the solution. I listed here 5 things that we look at as we fill out this information and collect this. We looked at who the owner is. We look at the fix, how easy it is to fix. What can we tell about fixing this vulnerability? We talk about a root cause, so identifying where to fix. So if it's a runtime vulnerability, fix has to be in the code, for example, where in the code. Is there an operational mitigation? So is there a way to overcome, like we don't need to upgrade the library, but we can delete it, or there is a firewall rule. So sometimes there is a workaround to mitigate the vulnerability without changing the architecture. And what is the impact of fixing the root cause? Maybe this specific vulnerability I'm looking at is actually not just the business impact of that is for multiple applications. So I'm actually fixing a lot of things together. So the root cause could be something that addressing would benefit the business more than just this particular vulnerability. So in other words, this is information that does not exist in the risk, the business risks, because it's just one vulnerability, but this root cause can introduce 9 or 10. So in the case here that I'm showing in this graph, we have 320 alerts raised by Wiz, a cloud security tool, that all map down to one vulnerable dependency that introduced a whole family of vulnerable dependency that then go into container and go into live into runtime. If I am a security engineer that happened to just analyze just one of the 320 alerts, what I'll find is just this alert might be very highly important to fix, won't be critical. But going back to the root cause, I might realize, oh, there is a root cause here that actually fixes 320 business critical risks. So from what we see and from conversations that we have, and Justin, I'd love your take on this, it's actually a major decision maker for organizations when they come to make decisions on what they're going to do with vulnerabilities.
Yeah, this functionality, just from the customer's perspective, is a game changer, because what it's really doing, if you really boil it down, is it's changing the conversation from how many tasks are there to how many things do I have to do to solve those tasks. And it's not a one-to-one mapping. And I think we all know that, right? Like, so how many times has there been a situation where I have a misconfiguration, let's say, it's highly critical. I go in, I create a ticket, I go to the developer, they update the parameters, everyone's happy. 6 days later, another vulnerability comes in, or another, maybe it's a lower severity. It's the same file. They were already just in there, and they go through the exact same motion. So they're replicating their efforts and wasting a lot of time, when the reality is, if that developer could have gotten 2 tickets done at once, and this is a simple example, they would have saved that entire life cycle. You're starting to measure the actual time saved by grouping these types of things together. And you made a good point. Even though customers are always focused on critical and high, they can inherently bang out medium and low issues just by doing simple grouped activities, that are kind of displayed here. I think the other thing that's really powerful about this is if you think about application security programs, typically when I see them, they're well understood to a certain level in the organization. Maybe it's up to the manager level, maybe sometimes the CISO level. But as you go up and up, because application security becomes more and more critical to the business, you lose the details of what you're doing. You can't explain all the nuances of patching a vulnerability, but you can say, yeah, I went to our critical application and I did this one action and I fixed 7 problems. Like, that's a very understandable thing for people, stakeholders who may not be as technical or application security savvy. So we're seeing the idea that it's almost like level two. Level one is all these scanners grouped together. Let's deduplicate the issue so you're not looking at the same problem 3 different ways. That's cool. That's a good step. You're still looking at one problem. What if I could make one problem 7 problems and have one single ticket and have all the details under one ticket so that I just make my time that much more efficient? We're changing it. Instead of, if you have a million issues, you can't solve a million issues. So your first level of logic is pick the issues that make the most sense and don't waste time on the ones that don't. The second is, how can I do things as fast as possible? That's what actions represents.
Yeah. Cool. I deliberately left out here on these factors the actual fix, because this is also a capability that's interesting. Like, what's the code line that fixes it, or what do we need to do? This is something that eventually, as the developer gets to fixing it, they want to know that. But the most important thing for organizations to realize, like, how easy it is there a fix available? And then, is this an architectural change that's going to break our code, or is it like a character change? Change your random function to a safe random function. It's like probably not going to change anything besides just make us more secure. Or is it, we have to rewrite this module, which will cause delay. So this is some of the even t-shirt size estimations that security team want to understand before they make a fuss about, like, this is a critical vulnerability, we have to fix it right now. And it's super important. To sum up, like, some of those factors in a consolidated way, and you can look at a slide later, is what are these? There is exploitability factors, like what can we say about the chance of this being exploited? What's the impact of not fixing? And I've added here more items that we're looking into, like what type of vulnerability it is. It's like denial of service, or is it a vulnerability that helps somebody to hack into my organization? Is SLA breach, compliance, contractual requirements, sensitive data involved? What is this impact? If there is, and then for some organizations, there is a way to measure some of them, at least from an app perspective. So that's looking at this chart I shared before. They can use some of these factors to start assessing these and enriching the vulnerability, the already known criticality that they have. So eventually, yeah.
Yeah, can I add one thing? And you're probably going to get to it in a second. I think that what is so interesting that's happening is by adding in factors of detail, what you're doing is taking the assumed risk that when you have a million issues and you ignore almost all of them, you're assuming the risk whether you like it or not. That's the reality of what's happening. What's really a better approach is to assume the risk in a logical way with data that says, yeah, I didn't patch this vulnerability because of these factors. Therefore, I spent my time in a better way. That's what audited management wants to see. They want to see consistency in decision-making, not randomly picking things because they're, you don't really have a better process. It's a much better way to assume risk, because the reality is, until we get to a point where there's an inbox of 0, you're always going to assume risk. There's always going to be stuff that you can't get to. So you have to have a logic of why you did that.
Yeah, absolutely. So besides that, the benefits of being able to have true risk and having that context is basically, it's an ROI. There's a positive ROI. It saves time and ultimately also save money. You have less criticals. It's not obvious, but most of the vulnerabilities, it is based on every measurement that we do and every other vendor that deals with vulnerability does, are lower than their actual severity they're attached to on average. So most of the vulnerabilities are false positives, are noise, are unreachable things. So there is always, the more business risk you go, the less noise and critical risk you have ultimately. Then you spend less time on these triage or even on workflow. So if you have an alerting workflow that is tied to the true risk and you want to block developers, alert them, send them Slack messages, you're sending them less messages and more focused messages. And every message has a higher true positive rate. And then ultimately, the software being delivered faster. So there is the cadence of innovating with software gets faster, and the entire organization benefits, because with blindly going and fixing anything, it's basically the tax load is as high as possible. So in the next few minutes, I'm going to share a little bit of what we do and some of the maturity steps that we see organization take. The first step I want to share is just classifying assets, and where Legit helps, and some generally ASPM tools, is the ability to automate a lot of these processes. So instead of sending a questionnaire, or in addition to doing that, or continuously creating an app catalog that says which applications are business critical, there is the opportunity today, which is becoming insanely valuable using AI, to understand what is the application actually doing and what are some of the impact factors of that application. So being able to say which application handles AI, touches financial data, leverages APIs. These are some of the analysis that could be automated and then being used to label these applications now with this context that can help make these decisions. In many cases, from what we see, this information is very static. So it's something that has been collected once a year or once in a period of time. And we started this conversation by saying we're at the highest rate of change. So things change at a rate that make these things obsolete very, very fast, and make changes that you cannot really count on saying, like, this app, it actually doesn't touch data, and then wait for a year and make this assumption for such a period of time. So one thing that is and is valuable is to be able to continuously classify, and something that Legit is working on and continuously, is not just to be able to create this context, but to be able to alert when a change happened that changes this classification. So for example, an API has been added, or somebody had connected a new data source or to this application that now makes it touch PII or business data. So part of our Legit context capability is to automate this process and then give you the business card for every application. So what is it internet facing? Is there a path to the cloud? What sensitive data is being handled? Is this exposing an API, etc.? So there's two sides here. One is creating this classification and using automation as much as possible to get a true classification. The second thing is continuously sync that. So with the change management, being able to catch the change that actually matters and then update the source of truth, whether you use an ASPM for that source of truth or you use an external CMDB or a tool in the organization to do that.
One comment that I hear a lot about is when you start to go down the path of classifying, let's say, issues, but in this case, applications, it's only as good as the score that you trust. And the problem is that every vendor has a score. If you can't exactly see where the score is being calculated or how the score is being calculated, or even having ability to add context that you choose to change the score, like business impact, then it doesn't mean anything, right? What ends up happening is a customer will say, this application is an 86. And then all of a sudden they get very curious about what 86 makes up. They don't agree with a few things. And now 86 doesn't mean anything because they can't trust what the number means. So the real thing that we're seeing is this shift into as much information and data as possible about why this number was calculated, even the ability in some ways to manipulate the number so that they can feel comfortable saying, I'm going to fight for an 86 because I know what 86 means, versus the vendor says 86, I might as well do it, right? That doesn't fly anymore because everyone has a number and all the numbers are different.
Yeah, absolutely. And we can share a few words about scoring in general. Like you said, scoring is very, very tricky. It's kind of like a double-edged sword. Like scoring is great because you can compare things and you can trust the score, but it abstracts a lot of information and it's never perfect. So if you have to be very tight, scoring hides away a lot of these details. And then being able to say, hey, like you said, why is it 86? Why is it 90? Why is it 70? Opens up a lot of questions that for some organization it's not the right way. So it always starts with actually finding the real data, understanding what data is there, like being able to access the raw information about the application. So we talked about the creation of an application catalog. And like there is a way to do this or automate a lot of this process today with ASPM tools that scans a very large environment and able to quickly look at the architecture of an application from the code to the cloud and determine some of these impact parameters just automatically. The next step right now is let's use these things in order to zoom in into the risk that now we care about, because now we have information about our business impact of the application. We're only missing exploitability. And this is something that now what you can do is look at the vulnerabilities that you have and start introducing into them exploitability information. We can start by looking into the things that, and here I use Legit's ASPM to look at things that are deployed to the cloud, handle sensitive data, and use AI. Ended up with 37 problems. Here's some of them coming from a source tool that actually have this combination of things. So you can use this now context, this application context, to say, what's the risk of not fixing? And even create this funnel or focus group of vulnerabilities to say, this is what I would like to focus right now. This is my definition of business critical. The information that's looking into the exploitability metrics is something that needs to be calculated from the path to the internet. So it has to do some architectural analysis. Something that we're able to determine in many cases is this path to the internet, like being able to say, you're looking at the code vulnerability, but actually whether you're going to deploy this or not, this code vulnerability eventually represents an internet-facing app. And by not fixing it, you're exposing this app to the internet. There is information that can come from the threat intel community or just from the web, like EPSS, the chance of something to be exploited, or CISA-KEV, which is the database of CISA for known exploitation vectors. So if there is an exploit that's known, it's being logged, and then you can say there is actually a vulnerability. The example here that I have here on the right side is a score. It's actually a scorecard. We'll talk about this in a second, but it shows you the different factors for a critical severity vulnerability. So this is a critical CVSS, but it's unreachable. It's unreachable and there is no exploitation information. Actually, it is internet facing, but the application doesn't have a business impact. And for my organization, it's not a FedRAMP application, so I don't care. So eventually, based on my decision-making that I'm gonna even explain to an auditor, I'm not gonna fix it, or I'm classifying it slow, mainly because I've determined this is something that cannot be exploited in my scenario. Cannot be exploited, and the application is not really important for the business that much for me to take an action. So this is something that eventually this type of information, tools like ASPM can actually, for the exploitability piece, bring together these pieces of data that eventually will give you the information on the exploitability factor. So at this point, what you can do is zoom in into a vulnerability based on, or use all these factors, like Justin mentioned before, just to select these group of vulnerabilities that you would like to address first. Like we want to just the exploitable, reachable, business critical applications. This is a first nice kind of filters that we can say, this is now our focus group for the next iteration of fixing our backlog. And then we'll move to the group that slightly is more expanded.
Yeah, one thing to add here is I think this really breaks what most vendors do when they try to break it down, right? So you said it first. Severity is the universal language of what to do first. Critical, high, medium, low. Everyone knows that. It's really easy starting point. But because those buckets are so big, you have to have further classification. So what ends up happening usually is critical is a range between 100 and 91, right? Or whatever the range is. Believe it or not, that's still not enough granularity to still figure it out, because if you have 87 92s, what do? You still have to make 87 choices of which one to pick. So by doing it this way, we've actually had scenarios where you have a critical vulnerability with a score of 36, or you have a medium vulnerability with a score of 92. And it's very, very interesting because it gives a much more granular view of what should I actually do and where do I want to make my choices. You're giving yourself a much larger range of pieces of data to choose within the buckets of severity, which is just such a large bucket. You have to start, you're doing it anyway. This is a more data driven approach.
Yeah. Yeah. So as a segue to that, the last component that we see is eventually once you have this data and you have the ability to zoom in, which is the second step, now you can establish some kind of a risk scoring mechanism. And again, this is not something that everybody wants. Sometimes we see organizations just define critical and define medium. So they use the factors to define the criticality level, define those buckets, but not go as much as to say, we would like to have a score. Something that ASPM's tool bring to the table and constantly evolving like we do is to be able to evolve this score to something that takes into account a larger set of factors. Because when you start writing rule sets and policies, you eventually end up, it can get very, very messy very fast because you have a lot of scenarios. It's a big decision tree. There's many situations. Saying a few words of where we see the future of scoring happening, scoring is something that the organization have to choose whether it's a helping tool, it's a decision helper, so they look at as they make decisions, or it's something they base their entire policy about. Like Justin said, score has to be explained. Has to be explained like why this was made, because these decisions eventually, if the score determines it's critical, we have to prove to somebody that this is the factors that we use. The score, especially in Legit or in other ASPM tools that we see, is getting more and more and more complex in terms of the number of factors that are coming in. The compliance framework, the SLA, the age of the vulnerability. So even as we spoke before about some factors, these factors actually hide away a lot of things. So for example, let's take a different type of risk. Let's take a secret, an exposed password. The internet facing here is not really, it's not really an exploitability metric, but it's really, is this secret if being snatched? What service does it let me log into? What data is the service has? Is this a valid secret? Is the secret, what permission does it have? Is it a SaaS service? So like an attacker can immediately connect to, or is it an on-prem service in my networks that requires network access? So as you go more granular about all of these factors, there's some interesting parameters and granular parameters that you can use. So we are today experimenting with using artificial intelligence and machine learning to look at additional factors, boil it down together, and use a score. And then the future we see for that particular area is to be able to become smarter than the person that writes the policy. So to suggest the policy itself and to say, I analyze the vulnerability, here it is, accept feedback from the customer, and eventually adjust it to have a score that works for every organization. So this is something ASPM tool, I think it's in the core. If you look at Gartner's and what they define as a core capability of ASPM, being able to risk score is one of them. But eventually, what the point I wanted to make and Justin talked about earlier, there is simpler ways of understanding what's critical. Once you have the data and you have the factors, you can basically just use it in a very, very simple way, just to find the cut of risk that it's absolutely important to fix. So using this like diagram as an example, here is some example of a very, very, very simple calculation that says, if we have something that breaks compliance, business critical app, and involves sensitive data and exposed to the internet, we have to fix it now. That's the fix now thing. And the only tip that we say to organizations that deal with it is the save criticals for houses on fire type of risk. So always start with saying, what is the absolutely risk that's critical for me? And define this and then walk back into the risk that's less important to fix. If you have a definition of critical, what is the houses on fire definition in your business? Then you can start working down the other heat zones in the heat map or other criteria. I'll just mention in one sentence as we reach the end, remediation context. We didn't talk about this, but again, it's a huge area where ASPM tools can help. Is basically transforming back the vulnerability into what's the remediation step? What's the actionable component? We've recently released root cause remediation, which is the ability to move away from a single vulnerability into what's the actionable step? What does this step do? and very soon also an assessment of the ease of fixing of this specific action, with path going down to like automated remediation. So so far we've had amazing responses, or eventually like the concept of moving from these seems to be something that everybody's now looking forward to when talking about vulnerability fixing, because I realize this is the natural step that needs to be done when we're talking about remediation context. And I'll just let me know if you have
Yeah.
anything to add on
No,
that.
last thing I'll say is I think that the remediation context here, last thing to add is this is becoming a huge factor for managers and organizations to help capacity plans. Because if you look at your environment and you see a million issues and you ask yourself, how many people do I need this year to solve that problem? It's an unanswerable question. There's no way to know what the actual impact is. When you go from a number of issues into a number of actions with these logical steps, then actions become much more manageable because you have context. How many tickets did we create this year? How many remediations did we have? You have those numbers. So as you capacity plan for the coming years or using resources, having a number of actions is a logical way to do it. Now, it's not just as simple as tickets, because actions are grouping of issues. You're actually burning down your amount of debt, technical debt that you have, simply by doing them in a logical way. You're still doing the same number of things, same number of tickets, same number of escalations each month and each week. So this becomes a critical way to look at your business and say, do I have enough people and resources, and how far can I get with that? Versus a number of issues that don't mean anything to anyone. I think that's the old world. We're transitioning into more of an actionable application security program.
Yeah, absolutely. And yeah, an example I've shown here, I've looked for show me actions that are connected to issues that have a higher score, which my definition is the watermark where I need to fix things. So eventually I end up with 90 different tasks, which if you just try to sum this column here, you end up with hundreds of individual findings. So eventually I say there's 90 actions that my organization needs to make, let's say this quarter, to fix that high and critical risk. All of them actually fix other types of risk in addition to that, because they actually target a larger problem and many more assets, but I'm actually fixing the root causes of these issues. To sum up, as I think we're nearing the last minutes of our webcast, there are too many vulnerabilities, and it's gonna get worse. So the only way to be successful in delivering software fast is to work with an elevated concept of risk. I think it's not a question anymore if you have a large scale program. It's something that everybody has to do. Just a question of how good you're doing this and how accurate and how smooth this is going on. There are several actionable steps depending on maturity levels that ASPM tools and also legit do, which begin with classifying applications and then assessing this impact of not fixing and the exploitability of an application based on analyzing of the environment. That's the magic or the secret sauce. The contextual risk approach is basically could be very simple. Like let's use just a few parameters like exploitability and path to the internet, or is exploit exist, and let's use just a business impact classification and start from there. So it's a gradual process. It doesn't have to be full blown at the first step. Risk scoring is something that could be used eventually. It's not fit for everyone, but it is something offered today by ASPM to actually gauge the risk, compare it to other tools and to other vulnerabilities, and get some kind of a quick assessment. It's getting more and more and more advanced as we speak. Last thing, remediation context. We talk about this. This is a third piece of context that needs to be brought into the vulnerability. It's a major time saver. It's a decision-making tool of what we're going to do because we can't fix what's unfixable, or we don't really want to take adventures and halt development. And it gives the confidence for developers to come, for security to come to developers and say, okay, I have some intel about like who needs to solve this and where and how. So I actually know this is not a big uplift, or it requires something that we can talk about. So these are kind of like the takeaways. And as you know, we're legit an ASPM platform dealing with these challenges and a few more. So you're always welcome to talk to us. If you're a customer watching this, happy to talk to you. Some of these capabilities available in the platform. Some of these are part of our really near-term roadmap. If you are interested in this domain, always happy to go down a demo and prove a value very quickly.